Hi, I'm Caitlin, and I am going to teach you how to set up an LCMS instrument in NanoFlow for sample analysis today. This protocol involves 4 steps: making your solvents, purging the LC instrument, setting up your column, and setting up your samples and your sample analysis sequence. So your first step will be to prepare your solvents. These solvents should all be LCMS grade solvents and LCMS grade additives to prevent any damage to the instruments, as salts and other interfering compounds can be very problematic for the mass spectrometer. So to do that, we have these solvents and these additives over in our mass spec fume hood, and those are the ones that should be used for this. So once you've made your solvents, these each need to be sonicated under vacuum for 5 minutes, and we use the sonicator in the HECT lab to do this. When you have your solvents made and sonicated, you'll want to pull out 15 microliters of your buffer A and set it aside for sample analysis and to fill a transport vial later. So once you've done that, then you'll take your solvent bottles and bring them up to the top of the instrument and place the solvent lines in the appropriate bottles, labeled A for aqueous and B for organic solvents. Once you have your solvent bottles in place, you'll open up the door to the pump and you'll open both purge valves. You have to turn these until they're all the way open, and you'll feel when they hit a stop point. Once you have your purge valves open, you'll go over to the instrument computer. Set your solvent composition for the nano pump to 50%, and under the More Options tab for the NC pump, you'll select to purge both blocks, and you want to do this for 20 minutes. You'll turn the purge on, and the instrument will deliver a warning that says this is a high flow and to ensure the purge valves are open. So this is just a second reminder to make sure that you had opened those purge valves before you stepped over to the computer. And then you'll come back in 20 minutes when the purge is concluded. Once the block's purge has concluded, you'll want to come back to the pump and close the purge valves. When you close these, make sure that they're finger tight. I like to tell people that if I can't open them after you close them too tight because they work when I do it. Over-tightening them can lead to damage. So with the purge valves closed, you'll then want to remove the pump outlet Viper line. And these nano Viper lines are extremely fragile, so be very careful while doing this. You'll notice the line has a tan seal at the end of it. If you pull out the line and notice that that seal is missing, please contact someone who's in charge of the instrument. Otherwise, if the seal is in place, go ahead and put a cap on the line and let it hang down. For this part, we will also open the column oven door. And then we will install this metal line. So the purge that we're going to do next is to purge the flow meter, which is the space back behind here where the solvents are mixed. And to do this, flow will come out of this outlet. So we'll install this stainless steel line here to ensure that no solvent will drip down into the electronics of the pump. Once that's there, we'll place a Kim wipe underneath it to collect any solvent that flows out during the purge, and we'll head over to the instrument computer to start the purge. So, in this same More Options window, we will select flow meter, and again, 20 minutes, and we'll turn the purge on. This time, the warning system that pops up will ask you to make sure that the purge valves have been closed again and that the column is not connected with the flow meter outlet. So that's where the stainless steel line is. If that's in there, the column's not connected, and so we're ready to start purging. And then come back in 20 minutes when the flow meter purge is concluded. So once you have finished purging the instrument, the next step will be to attach your column. to do this, you'll remove the stainless steel line that we put in place for the flow meter purge. So once the flow meter purge has been concluded, you'll want to return to the instrument and reattach the lines. So to start, we will remove the stainless steel line that we added in for the purge. We'll replace the caps. And place it back into its storage tube. So we keep this line down here at the left side of the instrument so that it's always available when it's needed. To reattach the plumbing system of the instrument, we'll take the line that we previously took out of the Viper outlet, take the cap back off of it, ensure that the seal at the end of the line is intact, and place it back into the Viper outlet. And here, same as the purge valves, you'll want to make sure this is finger tight. Over-tightening it can cause damage to the lines. So this line runs directly from the pump down to a valve in the auto sampler. And also flowing out of this auto sampler valve is another line that comes up through our column oven and all the way over to our nano source. And that is where we will install your column. So we have a couple of different storage systems for nano columns. You'll notice there are a few taped to the fume hood above me. Some we store in NMR tubes if they're short enough. And this is actually the packaging that the columns come in and where I currently have my columns stored. So to insert a nano column, you want to open up the package and very carefully with the plastic tweezers remove the column from the package without damaging the tip. As is the case with a lot of things we work with for nano LC, it's very fragile. Once you have it moved enough, you can start to pull on it with your fingers to remove the column from its case. Then you'll want to open the nano source to give you room to work with. This red union goes on close to the tip of your column to hold the tip of it steady. So very carefully insert the end of your column into the union and pull it through. This then sits here to hold the column steady, and that's closed over the top of it. To attach the end of the column to the lines that have the source of solvent flow, we remove this ferrule and insert it through the end of your column. So here you want the end of your column just barely sticking outside of this. Then you'll reattach it to this union. And place it here. These three knobs are responsible for adjusting the placement of your column. This one here adjusts the front and back position. So pull this all the way back before you close the nano source again to ensure that you don't slam the tip of your column into the ion transfer tube. So once that's back, we can close the source until it clicks. Then we can reposition the column by slowly moving forward. Until the column is closer. This here is actually a camera which feeds into the computer so we can look at the positioning with a program at the computer. To turn the light of the camera on and off, you can push this button here, and again to turn it back on. So you want to adjust the column forward until it's close to the ion transfer tube, right about here. And then you'll want to ensure that it's centered on the ion transfer tube. So here, this larger dial will move it sideways, which as you're looking at the screen will actually be top and bottom due to the position of the camera. So looking at the screen, I can see that the column is currently a bit too far to the left, which appears too high on the screen. So I'll adjust its sideways position until it is centered. You can then move the camera to the side so that we can adjust the top and bottom position. So here we can see that it is a little bit low. So we will just slowly increase until it is pointed directly at the center of the ion transfer tube. And this you can all do while looking at the screen of the camera view. We'll place the camera to the top and get started with column equilibration. Once you have your column positioned, you'll want to start with column equilibration. So to do this, we will start with our solvent percentage at 90% B, as this is what your column should have previously been stored in. And then nanocolumns have a typical flow rate of anywhere from 0.3 to 1 microliters per minute. I run my column at 0.8, so I'm going to set the flow rate to 0.8 microliters per minute. So the instrument will take about a minute to get it up to the proper flow, and the pressure will slowly increase. The pressure will depend on your column and will be somewhere around 200 bar at this flow rate for this column. As solvent starts to flow through the column, you'll see a droplet forming here at the end of your column. And this is when you'll want to turn the mass spectrometer from standby to on so that the solvent is actually flowing through the ion transfer tube. So to do that, we'll open this tune file, looks like a music note, and click here from standby to on. And now you'll see that the droplet is no longer there. So once your column has gotten up to pressure, which as you can see, ours is not yet, you'll want to let it equilibrate for about 30 minutes at this 90% B. Following that, you'll come here and switch your solvent composition to whatever your starting conditions of your method are. So for this one, my starting conditions are 2% B. And again, once the column has reached its appropriate pressure, for this column, it's about 400 bar under these conditions. You'll want to let this equilibrate for a further 30 minutes while you prepare your samples. So once you've gone through the first 3 steps of making your solvents and setting up and purging the instrument and getting your column equilibrated, you'll want to get your samples into the auto sampler of the instrument. So first, to prepare your samples, you will have no doubt gone through the SOP for whatever analyte you're looking for. You'll want to reconstitute your samples in anywhere from 5 to 30 microliters of the buffer A that you're using for your analysis that you took out at the beginning of the protocol. And then you'll want to have your samples in your vials. So to get your samples onto the instrument, we'll slowly open this cover for the auto sampler, and you'll see 3 trays here. So they are labeled blue, red, and green in the center of this auto sampler. So to add samples in a vial, just pick an open spot and set your vial in, and just make sure you remember where you put it. If you're using 96 well plates, like this one here, there is a well plate insert that goes into the auto sampler before your plate. That looks like this, and sets here to ensure your plate stays in the correct location. Position A1 of your 96 well plate should be in the back left. Once you've added your samples to the auto sampler, you just go ahead and close this door again. Additionally, there will be some extra buffer A left that you set aside at the beginning of this protocol, and you'll want to use this to fill your transport vial. What this is a vial of solvent that the instrument will use to pull up before and after your sample to clean out the needle and the injection loop, and you can also use it to inject your blanks from. So my method will use vial R1, so I'll locate R1, empty out whatever is in it, and fill it up with that extra buffer A that you saved behind. So I've already done this, so I'm just going to replace this file. And then we'll head over to the computer to set up a sequence. So to set up your sequence, you'll open this Excalibur program. And open the sequence setup view. So currently I have a previous sequence of mine open, but we'll start from scratch. So to start with a new sequence, the things you have to add into the method are where you put your sample. So I'm just going to put R1 here as the first sample that I entered, which will just be a blank sample. You always want to start out your sample runs with a blank. So the injection volume depends on your method. I tend to use 5 microliters for each of my methods. Some people will use anywhere from 2 to 5. Our injection loop can only handle 5 microliters as a maximum. And then you'll want to name your file. I'm just going to name this blank 1. You can give it a sample name where you can be more detailed as to what this sample is. For a blank sample, I'm just going to leave it as is. You want to select the path where your data will be saved. So right-click, Browse, and then we save the data under the D drive here. So you'll want to choose your folder and find an appropriate place to save your data. So for now, I'll just save it in mine, in my April folder. And then you'll want to load an instrument method. So again, right-click and browse, and find the method you want to use for this analysis. So I'm just going to open up the method I've been using previously for an analyte called DHBMA. And now you're ready to add the next line of your sequence for your samples. When you have your sequence completed with everything in it that you need to run, you'll want to make sure you save it as a new sequence and save it in the same place where you set your data path. And then you'll want to hit this Run Sequence button. And so to do this, this will open up this window. You'll want to double check that you're running the rows of the sequence that you think you should. Right now my sequence only has 1, but if you have 10 samples or 20 samples, make sure that this says what you think it should. And then hit this OK button to start the sequence. While your sequence is running, it will show the samples currently running here in this acquisition queue status. And you can click this real-time plot view to see the current data that is being processed. We don't currently have a sequence running, so this says it's waiting for it to start. To analyze your data, you'll open the Excalibur Qual browser program. You'll open the sequence that you're interested in looking at. So I'm just going to open my latest sequence. And then you'll select a sample. To change the layout of what this window here is showing, you go to File, Layout, and Apply. And then you'll want to find the layout file that has already been saved that is the appropriate layout for what you're looking for. So I'm going to apply this layout that I've used for these types of samples. And so now you can see what your sample looks like and what the pressure is. And this layout is customizable for whatever you want to be able to look at when your sample analysis is finished. To do that, you'll right-click and select Ranges. And this will allow you to click the scan you're interested in looking at, the particular fragment ion you're interested in, as well as look at things like pressure or column oven temperature or any number of other metrics that the system collects while it's running. To open a different sample, you just click on a different sample name, and you can see what the sample looks like.